Popular string functions in the C programming language. Strings in C may look simple, but behind them lies a powerful set of functions that every serious programmer must master. Popular string functions like strlen, strcpy, strncpy, sprintf, and snprintf give us precise control over text processing, memory handling, and data formatting. Skills that are essential in real-world applications, embedded systems, and performance-critical software. Understanding how these functions work not only helps you write safer and more efficient programs, but also reveals how deeply it gives you control over memory and data at a low-level program. strlen. strlen scans the string from the first character until it reaches the null terminator. It returns the number of visible characters. It returns the number of visible characters, not including the terminator. Because the length cannot be negative, the return type is size underline t. You can pass either an array name or a pointer to a character buffer. In this example, we have two strings, str1, which is a character array initialized with the text picobits, and str2, which is a pointer to the string literal hello. When we call strlen str1, the function counts the number of visible characters in picobit and returns 7. But there are 7 characters and the termination null is not included in the length. Similarly, strlen str2 function measures the length of a string hello and returns 5. Again, excluding the null terminator, the program then prints these values, so output becomes strlen str1 equals 7 and strlen str2 equals 5, clearly showing how strlen function reports only the character counts of the string contents. Sizeof. Unlike strlen, which scans the string in memory and counts character until it reaches the null terminator, the sizeof operator does not read the string at all. Instead, it simply reports the total amount of memory in bytes that has been allocated for the object at compile time. When sizeof is applied to a character array, its result includes the null terminator because the array's full storage size is counted. However, when sizeof is applied to a pointer, it returns only the size of the pointer variable itself, not the length of the string it points to. This is very important. Does sizeof work at runtime? No. In most cases, sizeof is evaluated at compile time, not at runtime. It does not depend on program. It does not depend on program execution or data values. It depends only on the type of this expression. It depends only on the type of expression. The only rare exception is when applied to a variable length array or VLA in C, where it may be evaluated at runtime. The only rare exception is when applied to a variable length array in C, when it may be evaluated at runtime. But For normal arrays and pointers, it is strictly a compile time operation. In this example, we define two strings, A, which is a character array initialized with the text picobit tag, and B, which is a pointer to the same string later on. The string picobit tag contains 12 visible characters, so strlen function returns 12 because it counts only the characters up to but not including the null terminator. However, size of a return 13 because the array stores all 12 characters plus the hidden null terminator at the end. For the pointer B, strlen B also returns 12 since it still measures the length of the string in memory, but size of B does not measure the string length. Instead, it reports the size of the pointer variable itself. On a 64-bit system, a pointer occupies 8 bytes, so size of B prints 8 regardless of the string's length. This clearly shows that strlen function works on string content while size of operation reports the memory size of the variable on or type, which may be completely unrelated to the actual string length. strcpy. strcpy copies all characters from the source string into the destination buffer until it reaches the null terminator. Because strcpy does not check the destination size, you must ensure the buffer is large enough to hold the entire source plus the terminator. In this example, we start with the character array src, which stores the string picobit, and another character array test with a capacity of 20 bytes, which is currently uninitialized. When the strcpy function executes, it copies the entire string from src into dest, including the null terminator at the end. After the copy, the contents of dest becomes exactly picobit, occupying 8 bytes in memory, 7 characters plus the null terminator. Finally, when we print the result using printf function, the output displayed on the string is dest equal picobit, confirming that the string has been successfully copied from src to dest. strncpy. strncpy copies at most n characters if the source is shorter than n. If the source is shorter than n, the remaining bytes are filled with null. If the source is longer or equal to n, the result may not be null terminated. Therefore, in professional C code, we manually add a terminator. In this example, the string src contains the text picobit, which has 7 characters plus a null terminator, while the destination array dest has a fixed size of only 5 bytes. Then the strncpy function runs. It copies only the first 5 characters from the src into dest, which are p, I, c, o, and b. However, because all 5 bytes are used, there is no space left for the null terminator, meaning the string in dest is not safely terminated yet. To fix this, the line dest size of dest minus 1 equal null, manually placed the null terminator at the indexed and the index for ensuring that dest now contains the valid string pico. As a result, when printf function executes, the output on the screen becomes dest equal pico, showing how strncpy truncates the string when the destination buffer is smaller than the source. Formatted copy function sprintf. Sprintf writes the formatted text into a character buffer just like printf writes to the screen. However, sprintf does not limit the number of bytes written. So if the buffer is too small, memory overflow occurs. This is why modern C programming refers snprintf. In this example, we first create a character array name buffer with a space for 20 characters, and then the statement sprintf function formatted the text sum equal 42 and stores it directly inside buffer instead of printing it to the screen. The expression for plus 2 evaluate to 42, so the final string written into the buffer becomes sum equal 42. The function also returns the number of characters written, which is stored in the variable written. Since the string sum equal 42 contains 6 characters, written receives the value 6. When we print the results, printf displays buffer equal sum equal 42 and printf written outputs written equal 6, confirming both the stored string and the number of characters generated by sprintf. Number 6, formatted copy functions snprintf. Snprintf is the safe alternative to sprintf. It prevents overflow by limiting how many bytes may be written, including the null terminator. Even if truncation occurs, the buffer remains properly null terminated, making snprintf one of the safest string functions in C. In this example, we define a character array name buffer with a capacity of 10 bytes, and then we call snprintf buffer size of buffer the value equal %d12345, which attempts to write the string value equal 12345 into the buffer, but only up to the 10 characters, including the null terminator. The full output would be 11 characters long, so only value equal 123 fits in the buffer, and the string is safely truncated while still being null terminated. The function returns the total number of characters that would have been written if enough space were available. So written becomes 11. When we print the results, buffer equal value equal 123 shows the truncated text, and written equal 11 reveals the original intended lengths. Since the written is greater than or equal the buffer size, the program prints the message output was truncated to indicate that the data did not fully fit in the allocated space. Comparison table. In this table, we compare 4 commonly used string handling functions in C. strcpy, strncpy, sprintf, and snprintf. Each one behaves differently when it comes to safety, buffer limits, and null termination. strcpy is considered unsafe because it copies an entire string without checking the destination buffer size. If the source string is larger than target buffer, it will overflow, which can easily lead to crashes. It always adds the terminating null, but because it has no length limit, it's not recommended for professional or secure code. strncpy is only semi-safe. It always you. It always you to specify the maximum number of characters to copy, which helps prevent buffer overflow. However, it does not always append the null terminator if the source string is equal or longer than the specified limit. This means your destination buffer may end up without a proper C string terminating unless you add it manually. It's typically used when copying into fixed size buffers. sprintf is another safe function because it writes formatted data into a buffer without checking the available space. If the formatted output is too large, it will overflow the buffer. Although it does add a null terminator, the lack of boundary checking makes it dangerous and outdated for modern secure programs. Finally, snprintf is the safe alternative. It always respects the buffer size you specify and guarantees proper null termination as long as the buffer size is greater than 0. This makes sprintf the recommended choice for formatted output when working with a string in C. It helps prevent buffer overflows and it's widely used in professional and embedded applications. Summary. In our next video, we are going to explore enumerations in the C programming language. Enumerations or enums play a very important role in making your code more readable, more organized, and easier to maintain. Instead of using raw numbers, enums lets you define meaningful name for values. This helps prevent mistakes and results in cleaner, more professional C code, especially in large projects. At the end of this video, you can find links to more lessons in our C programming series. And if you wanna be notified as soon as the next video is released, make sure to subscribe to the channel and stay connected. Thank you so much.